I'm going to show you how to do an orbital notation and an electron configuration. For certain elements, we'll just pick some pretty easy ones to start off with. So let's say you had to write what's called an orbital notation for lithium. So lithium has 3 electrons because it's atomic number 3. So we have to show 3 electrons in this orbital notation. Now, the arrows that I'm going to draw stand for electrons, okay? And the boxes stand for orbitals, or an orbital, okay? So lithium, we have to put 3 electrons in. The first thing that we're going to do is follow what's called the off-ball principle, which means you always put the electrons in starting at the lowest energy level to the highest. Okay, so let me start doing that. We're going to always start at the lowest. That's the 1s. So I put 1 there. Okay, now there's another rule that's called the Pauli exclusion principle, which states that you can only put 2 electrons per orbital and they have to have opposite spin. So to show that they have opposite spin, I draw 1 arrow up, straight up, and 1 down. Okay, that means opposite spin. Okay, Pauli says you can only put 2 per orbital. Okay, we have 1 more to go, so it's going to go in the 2s. See how I went to the next highest energy level? I didn't jump way up to like the 7s or anything. You always go from the lowest to the highest. That's called the off-ball principle. Now we can write the electron configuration. So it would be, for lithium, it would be 1s, count 1, 2, 2s, 1. Okay? The exponents stand for the number of electrons, and so there's 3 there, so that matches 3. Okay? Let's try one that's a little bit harder, and there's one more rule to know. So let me erase. All right. So now the next rule is called Huns Rule that we'll follow, but we got to follow all 3 rules. Okay, let's do one like oxygen. Oxygen is number 8, so it has 8 electrons. So I'm going to show 8 electrons. Off-ball, always start at the bottom and work your way up. 1, 2. Pauli, only 2 electrons per orbital. They have to have opposite spin. 3, 4. Okay, here's the new rule. The new rule is called It's called Huns Rule. And let me scroll this up a little bit. Okay, now Huns Rule states that when you have orbitals of equal energy, each get 1 electron before they pair up. Now I got 4 more to put in because I already put 4 in. I got to put 4 more in. So Huns Rule says each orbital of equal energy each gets 1 electron. Oh, well, I don't know why that's doing that. Each gets 1 electron before any get 2. So I put 1, 2, 3. I'm going to put 1 more in, 4. Okay? And so there I put 4 electrons in. Okay? And so if you count 1, 2, 3, 4, 5, 6, 7, 8. Now, Huns Rule, each orbital got 1 before I started pairing up. Okay, now we can write the electron configuration. 1s, 2. 2s, 2, 2p, 1, 2, 3, 4. All right, I'm going to try a little bit harder one now, following all 3 rules. Okay, I got to erase this thing. I think there's a way to erase all quickly, but I don't remember how to do it. So here we go. Let's do one that's a little bit harder and it's a little bit longer. Let's do nickel. Okay, so nickel is number 28. So I got to put 28 electrons in. So we're always going to start at the bottom. Here we go. 1, 2, 3, 4. Off-ball, start at the bottom and work your way up. Pauli, each orbital can only have 2, but they have to have opposite spin. Okay, Huns Rule. Orbitals of equal energy each get 1 before any get 2. Okay, I got to put 28 total in, so I got to keep going. Okay, there's 6, 7, 8, 9, 10. I got 18 more. 11, 12, 13. See how I'm following Huns Rule? 14, 15, 16, 17, 18. Okay, so I got 12, 14, 16, 18, 20, 22, 24. I got 8 more to go. Okay. 19, 20. See how they have opposite spin? That's the Pauli exclusion principle. Now, I'm at nickel, and I have 1, 2, 3, 4, 5, 6, 7. I got 8 more to go, I think, actually. I got 8 more to go with nickel if I counted right. Okay, because I got to put 28 in, so I got 12, 14, 16, let's see here. 6, 12, 14, 16, 18, 20. So I got 8 more to go. Here we go. 1, 2, 3, 4, 5. Now, see how I put them in following Hund's rule? They all have the same spin. But now I got to go 3 more. 6, 7, 8. I hope I counted right. Yep, I think I did. All right. So now we can write the electron configuration. Start at the bottom. 1s2, 2s2, 2p, 1, 2, 3, 4, 5, 6, 3s2, 3p, 2, 4, 6, 3p6, 4s2. Notice how the 4s comes before the 3d because it's lower in energy. 3d, 2, 4, 6, 7, 8. Okay, that's it. Now if I add all the exponents together, all right, it should add up to 28. And if you count them up, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, there's 20 and 8. That equals that, so that is correct. Okay, that's how to do an orbital notation. Make sure you follow the Pauli, or first start with the off-ball principle. Start at the bottom and work your way up from lowest energy to highest. 2, follow the Pauli exclusion principle. Orbitals can hold a max of 2 electrons and they have to have opposite spin. And then follow Hund's rule. Orbitals of equal energy each get 1 electron before they pair up. Okay, that's it.